Okay, and welcome to the second review tutorial. In this final installment, we will be reviewing how to add and subtract rational expressions. So when we turn over to example 3, you can see that we're still dealing with the same two fractions, but this time I am trying to add the fractions. When you're trying to add fractions, you must have the same denominators. Must have common or same denominators. Very much unlike when we're multiplying. When we're multiplying, we can just multiply whatever the denominators are. When we're adding or subtracting, we must have the same denominators. So now our steps: first, factor the denominators. We want to see all the little factors that we have in the denominators. So let's factor the denominators. This first denominator can factor into an x plus 2 and an x minus 2. It's a difference of two perfect squares. And I'll just kind of scratch out what it used to look like, and now I've got my factored form. This denominator doesn't have anything to do other than say, hey, it's an x plus 2. So now our second, so once we've done that, our second step is find the LCD. The LCD is all of the prime factors that we see. So we're looking at the denominators. I see an x plus 2, and I actually see an x plus 2 in both denominators. So that's okay, they already have them. So the LCD in this case is going to have to include the x plus 2. But what else do I see? I don't see anything else from this denominator. I do see an x minus 2 factor. So I will need an x minus 2 as well. So I've got the x plus 2, and I've got the x minus 2, and there aren't any other different factors. So there's my LCD. Step 3, multiply the missing pieces from the LCD, the missing pieces of the LCD, to the, I'm just going to say the appropriate fractions. Whatever fraction needs the missing piece, we're gonna take that fraction and multiply by that missing piece. So for example, the LCD is x plus 2 times x minus 2. That actually means that this denominator is already ready. So this first fraction is not going to change. It already has the x plus 2, and it already has the x minus 2. So the numerator is just going to be the same. Not doing anything with this first fraction. But the second fraction only has the x plus 2. It's clearly missing the x minus 2. So I'm going to go ahead and put the x minus 2 in the denominator, but I also have to put it in the numerator. And since I put something next to these things, maybe I put them in parentheses. Now I'm going to have the same denominator here, the x plus 2 and the x minus 2. What I need to do in the numerator, though, is I'm going to need to FOIL. So I'll do first, outer, inner, last, multiply those products together. I get x squared. The outer terms are negative 2x. The inner terms are positive 1x. That adds up to negative 1x. And then my last terms are negative 2. So now I have two fractions that I want to add, but they now have the same denominators. So I can combine them together into one fraction with those denominators. Now let's see what I have. I'm taking x squared plus 3x plus 2 plus x squared minus x minus 2. So I'm really just going to gather my like terms. I see that I have 2x squareds. I see that I have 3x, take away x is going to be 2x. And I see that I have 2 minus 2, which actually is 0, so I don't really need that. Now what's left in the numerator, I know this can factor. I don't know if it's going to help me later, but I'm going to see if when I factor this, I have a common factor that will cancel out with something in the denominator. There's a GCF. It's a binomial, so there has to be something funny going on, and it's a GCF. I'm going to take the 2x that the GCF is out of each of these two terms, and I'll be left with x plus 1 divided by the x plus 2, x minus 2. Okay, now that I see, once I factored it, it's not really going to help me. There are no factors in the numerator that are common with the factors in the denominator, so there's nothing else to cancel away. So I would have been fine to stay right here with this answer, but since I've already gotten to this answer, I'm going to go ahead and circle this, box that in, and we're finished. A little bit more complicated to add fractions. Let's look at our final example, which is the same two fractions again, but this time we're subtracting them. But it's going to be the same exact steps. I need to factor the denominators so I can find the LCD. Same factors here, x plus 2 and x minus 2. Let me just kind of scratch this out. There's nothing to do here. So it's the same LCD. The LCD is still going to be the x plus 2 factor and the x minus 2 factor. So that means that this fraction is missing that piece, the x minus 2. So I'll go ahead and put in the x minus 2 and the x minus 2. Maybe put these in parentheses again. And let's see what we've got. In fact, this time I'm going to put them both as one big fraction because I know that now they're going to have the same denominator. So I might as well just put it all as one big fraction, and then I'll clean up my like terms. Nothing's changing from this first numerator, x squared plus 3x plus 2. But watch out for the second numerator. I know I need to FOIL this, but I'm also going to be subtracting all parts of that answer. So I'm going to keep this in parentheses. When I FOIL this, I get x squared, and negative 2x and positive 1x makes my negative x, and 1 times negative 2 is my negative 2 again. But this time with the subtraction problem, I'm going to be subtracting all three parts of this numerator. So please watch out for the subtraction. So I've got x squared plus 3x plus 2, and then minus x squared plus x and plus 2. I'll gather those like terms in a minute. Get the denominator here. So now let's see what we have when I gather the like terms. I've got x squared take away x squared. Well, those actually cancel away. I've got 3x and 1x make 4x. And I've got 2 plus 2 make 4. Now I know what I have in the numerator. I know that I can factor it because there's a little GCF, but I know that I can see what's going to happen. It's not really going to help me. If I take out the 4, I'm left with x plus 1, and that's actually not going to cancel anything from the denominator. So I'm actually fine with your leaving it either here as the blue form, or if you want to factor it just to see the factors and see that nothing's going to cancel, I'm going to circle both of these because either one of these is an acceptable answer. Thanks for watching this second tutorial on adding and subtracting rational expressions. We'll see you for practice and the quiz next class. Oh, great. See ya.